What a spring it was across north and central Texas, from the total solar eclipse to near record rainfall to one of the most active tornado seasons that we've had in years. What better place to discuss all of that, plus a whole lot more, than right here in our brand new video podcast? I'm meteorologist Matt Stolley at the National Weather Service in Fort Worth, and we are on air. Good Monday morning to everybody out there. It is Monday, June 17th, 2024. Welcome to the premiere episode of On Air, a brand new video podcast by your meteorologists right here at the Weather Service in Fort Worth. We've got a terrific first episode for you today. We're going to be taking a look back at the active and exceptional spring that we just finished off now that we're heading into weather that's a little bit more typical for summer finally. We've got Daniel Huckabee coming on to help us break all of that down in the Weather Spotlight segment. We're also going to be getting into a great Q&A segment talking about why sometimes the tornado threat can increase during the evening and overnight hours. And we'll also be taking a look back at one of the many severe weather events from the last week of May on the radar recap. So that plus a whole lot more here on the first episode of On Air. Before we get into all of that, though, since this is the very first episode, I want to take just a minute or two to talk about what this podcast series is going to be, and also, maybe more importantly, what it's not going to be. Let's go ahead and talk about that just for a couple minutes here. From us, you are usually or very used to seeing all information that we provide kind of boiled down to these three main questions, which are what, where, and when. Because really, at the end of the day, that's the weather information that you need in order to make a decision. Whether it is something as simple as what you're going to wear tomorrow, or maybe if you're going to cancel your event on the upcoming weekend because of rain chances. So everything that we provide is essentially covering those three critical pieces of information about the forecast, whether it's a forecast graphic or a watch, a warning, an advisory. It all is sort of boiled down to those three key elements. Now, for us, there's so much underlying science that goes into determining those things. So behind those three W questions is this massive looming why. And that's really where we're going to spend a whole lot of time in this podcast, is going into the why. Why did that forecast look the way that it did? Or why did we issue a warning or not issue a warning on a particular storm on radar? So if you are someone that really enjoys sort of the behind the scenes aspects, the why behind the what, where, and when, I think you're really going to enjoy this series because we're going to get a little technical at times. We're going to get into meteorology as a science and go into some kind of advanced concepts sometimes. So I hope that you will find that interesting. And if you know somebody that would really enjoy that, be sure to hit the share button as well so that they can check out this series too. So before we get into all this, I also want to mention what this series is not going to be. So first of all, we're not going to be focused too heavily on any one particular upcoming forecast. The reason for that is by the time we record this and we publish it and you have time to sit down and watch it, that forecast has probably changed a little bit since weather data is always evolving as we get closer and closer to an event. So for the latest forecast information, always be sure to head over to our website at weather.gov/FWD, as in Fort Worth, Dallas, and check on the latest forecast right there. So another thing that we are not going to do on this podcast is get outside of our forecast area. So we are responsible for these 46 counties in north and central Texas, which runs from the Red River southward through the Metroplex, of course, down through Waco, Temple, and Killeen. And then out east, we cover not quite to Tyler, and out west, we cover not quite to Abilene. So that's the same area that we're going to be focused on in this podcast as well. If there is a hurricane headed for Florida or a snowstorm in Amarillo or flooding in Houston, we're really not going to be talking about it here unless it somehow also is pertaining to our weather that we've experienced. So, lastly, what we will not be doing is anything like this or like this, and we definitely will not be doing this. So if the clickbait gimmick content of YouTube is what you're after, you're going to have to seek that out elsewhere because you will not be finding that here. All right, without further ado, let's get into the spring and start recapping some of that. The spring really got off to a start with the total solar eclipse. And wow, what a breathtaking experience that was. I hope you had the chance to check that out. We got really lucky with morning stratus clearing out just in the nick of time around 1 p.m. to offer a pretty good view for most locations. I hope that everybody enjoyed some of the extra bonus content that our office put together leading up to the eclipse uh, from forecasts to historical data. Uh, this is also from our webpage as well, which I'll link down below in the description if you still want to check this out. Um, but what a breathtaking experience that was. Here's a photo from one of our employees that we took, but I will just say that no picture or video can ever do a total solar eclipse justice. That was the first one that I've ever seen in person, and it was nothing short of breathtaking. So if you've got a chance to check one out, be sure to do that. I think the next one in our forecast area here isn't for another 300 years, and I don't plan on being around for that one, but there is another one in Oklahoma, and I believe it's 2045. So that one for a short drive up I-35, totally worth checking out. I believe it's 2045. Somebody can correct me on that if I'm wrong. But what a breathtaking way to sort of kick off the spring. Now, ever since then, and well, even leading up to the eclipse, it's been nothing short of a busy spring season for us. We've had widespread rainfall across most of the state, including in our forecast area. Locations back west of I-35 have seen anywhere from about 20 to 30 inches of rainfall so far year to date. And areas to the east have picked up 30 to 40, and in some spots in excess of 45 inches of rain already this year. That's basically their entire annual normal rainfall just in the first half of the year. So some very impressive totals that we've seen so far this year. For DFW specifically, this is a running accumulation so far this year. And if you remember 2015, 2015 was the wettest year on record in over 120 years of records for the Dallas-Fort Worth area. And 2015 is the blue line here. By the way, shout out to the folks at the Iowa State site for making all of these plots so easy and readily available. These are all fantastic. But what you can see about the red line, which is this year, is that through most of the spring, remarkably, we actually kept pace with 2015 as far as rain totals go. Now, also in 2015, we had a whole another second round of rainfall during the fall and early winter. So we'll have to see what this fall holds for us, but nothing short of impressive that we were able to keep pace with the wettest year on record through the first half of the year. Now, unfortunately, you don't really get just beneficial rainfall during the spring in this part of the country. Uh, any sort of widespread rain that you get is often accompanied by severe weather. And the tornado count for this year just goes to show that we are up to a confirmed 31 tornadoes so far this year. And that's really also one of the most active seasons that we've had since 2015 also. The 2022 season was pretty active. That's a total of 49 for the entire calendar year. A lot of those came in the late fall and winter though that year. So as far as a spring is concerned, you really have to go back to 2015 to find a more active spring tornado season. That also is shown pretty easily by how many severe thunderstorm and tornado warnings that this office has issued so far this year. This is a running count up through mid-June, and 2011 takes the cake, but we have also kept pace with 2015. We're only off by one warning. We've issued 431 severe thunderstorm and tornado warnings so far this year. 2015 had 432, so we are as close as you can possibly get in that running there. And as far as flash flood warnings are concerned that we've issued, 2015 has slightly outpaced us on the number of flash flood warnings, but still far and away uh, at the top end of the spectrum for flash flood warning issuances that our office has had so far this year. Now, unfortunately, uh, the only way to get rid of drought in Texas and many other parts of the country is with an episode of very heavy rainfall and significant flash flooding. And that's been no exception this spring. So if you remember back just to last year, so this is the drought monitor from last September, pretty much our entire area was in either an extreme or severe drought with pretty bleak conditions across, especially central Texas. Well, it's no surprise that the rainfall this year has completely erased all of the drought from essentially the entire eastern half of the state. So, as of today, none of north and central Texas have any drought conditions, which probably does not come as a surprise based on how much rainfall that we've had this year. The other piece of good news is that all that rainfall has acted to fill up all of the area lakes. So each one of these circles on this map is a lake or reservoir. And for our forecast area, they are almost all sitting at 90 to 100% full. So you really can't ask for a better situation in that regard heading into the summer months to have all of the lakes full. This is probably one of the best cases that I've seen since I have been here for sure. Uh, and unfortunately, you do need a lot of rainfall and some flooding to come along with that in order to refill all those lakes and allow the environment here to continue to survive and to thrive. Now, to help us recap more of the spring, we have our local data, stats, and climate records guru, Daniel Huckabee, coming on the Weather Spotlight. I caught up with him over the past weekend, and we talked about a whole host of topics, including the most moistest May. I think I'm using that right. All right, without further ado, it is Daniel Huckabee in the Weather Spotlight. Daniel Huckabee, thank you so much for coming on and being our very first guest on the OnAir podcast for the Weather Service here in Fort Worth. How's your spring been going? It's been nothing short of chaotic for us here, but how have you been doing?
Absolutely. We've issued many warnings. We didn't beat 2015 in terms of the number of warnings or rainfall or the number of tornadoes, but it's been one of our busiest springs in a long time.
It certainly feels that way. It feels like ever since early April, it's just been pretty much nonstop. So we talked a little bit earlier in the podcast about the flooding rainfall that we've had, but just how exceptional has this really been for us?
Well, it was one of the wettest springs on record across all of North and Central Texas. DFW Airport had almost 20 inches of rain. We had some locations across Central and East Texas that had more than 30 inches just in that 3-month period, March, April, and May. That's more than twice what the normal value is for spring and well over half what the normal annual total is. So a lot of rain in a short period of time, and that's what leads to flooding.
Yeah, for sure. It's nothing short of remarkable to see some of those totals, especially like across the southeast where they've almost gotten an entire year's worth of rainfall just in the spring. So, what gets a lot of attention here too is the impact of things like El Nino or La Nina. So, was the fact that we're coming out of a El Nino winter and that continued into the spring, was that a factor? And if so, how much of a factor was it?
Well, we had a pretty strong El Nino during the cold season, and that helped to start our precipitation surplus over the winter. and helping us to get out of this long-term drought that we had been in. But the El Nino conditions started to wane during the spring. Now, we do tend to be wetter than normal during the spring months when we have El Nino in place, but the main focus has been what the pattern has set up. We've had exceptionally strong ridging over Mexico to our south and to our north, particularly during the latter half of spring. We had persistent troughing, and that really intensified the jet stream between those two areas. And we just stayed in that active pattern with embedded storm systems bringing us one event after another. And all that to say, I don't think we can pin this all on El Nino, but I think there are some similarities with some previous El Nino events, most notably 2015, and even much earlier in 1957. Those were both El Nino springs, where we got enormous amounts of rainfall that ended multi-year droughts.
Yeah, we were talking a little bit earlier too about how close to being on pace with 2015 that we had been so far this year, which was pretty impressive to see given how remarkable that year was. So
Exactly.
if El Nino isn't necessarily the whole story for the rainfall this spring, as we head into summer, is it going to still be much of a factor at all for us?
Well, the El Nino Southern Oscillation, or ENSO, as we call it, it has three phases. El Nino's one, its opposite, La Nina, is another, and then the intermediary phase we call ENSO neutral. So there's actually three phases, and we oscillate between those three phases. It turns out that the phase typically changes during the Northern Hemisphere summer, so it gets much more difficult to make predictions on seasonal timescales using ENSO once we get into the warm season. So it's not the best predictor for the summer months.
Yeah, that makes a lot of sense. So maybe at some point later on we'll have to have you back on, and maybe you could talk about how that influences us for maybe the winter months and the cooler season when it is a little bit bigger of an effect. So all that being said, what can we kind of say about the summer outlook, and does the fact that we've been so exceptionally rainy this spring, does that sort of continue or have an effect as we head deeper into the summer months here?
So we can't really use ENSO, but spring rainfall, what happens during the preceding season, is really important for a summer outlook. And it turns out when we're really wet in the spring, we tend to delay the onset of the extreme heat. So we may not have our first 100-degree day until later than usual. It's not to say that it won't be hot, but we do tend to mitigate the heat when we have a lot of healthy vegetation, a soil moisture surplus, all of those things that come with a wet spring. So essentially what happens is when the sun shines on the ground and there's healthy vegetation, moisture, a portion of the sun's energy goes into evaporating that moisture. So less is available to actually heat up the ground, which in turn heats up the air. So you can imagine a day after a rainy day is milder than a day after a day that didn't rain, all things equal. Now that impact is going to wane as the summer progresses. Of course, it's going to be hot. It's always hot in the summer here in Texas, but at least we should be able to reduce those daytime temperatures a bit.
Yeah, and one thing too that's really interesting about with how much water there is to evaporate still is you and I were talking just the other day about what impact that has on sort of the humidity and the dew points. And we were kind of surprised to find that several months so far this year have actually had really exceptional dew points for us. I'm going to call up real quick here the top 10 lists for dew points so far this year by month, and these are just average dew points through the course of the entire month. But what's interesting is that this year has been in the top 10 out of 80 plus years of data for dew points essentially. And February was the 4th highest, March was the 5th highest, April 7th place, and May now 3rd place for some of the highest dew points here. So I'm curious to get your take more on exactly what's going on with the dew points, how they've been able to stay so steady, and also what that means for how they're going to evolve this summer.
Absolutely. Well, 4 consecutive months we've been in the top 10. No other year can stake that claim. We actually hit a dew point of 78 degrees in early May. That's the earliest ever in a year that we've accomplished that at DFW Airport. So an unusually humid year. If you thought it was humid, you were right. But just a little explanation of what the dew point is. You hear a lot about the relative humidity, and that's tied to the temperature. But the dew point, whatever that value is, tells you specifically how much moisture is in the air. So we meteorologists like to use that to really assess how much moisture content the air has. But one thing, if you could show the map of the Gulf of Mexico there
Yeah,
and how
absolutely.
extraordinary May has been, what this map shows is that dark blue area, that is record highest average dew point for the month of May. Now you see that covers a lot of the eastern half of Texas, up here into north and central Texas, also Louisiana, Arkansas, but most notably all of the Gulf of Mexico. Now we have prevailing southerly winds here in the Western Gulf, so all of that moisture blowing up into the Lone Star State. Now I mentioned earlier that persistent ridge that's been in place across Mexico. That's the same upper high that we talk about in the summertime that brings us hot and rain-free weather. Well, it's brought exceptional drought to Mexico. What has it done for the Gulf of Mexico, where it's also been parked over? Well, it means that those sea surface temperatures are warm. It means more moisture is evaporating into the air above the Gulf. And as I said, those southerly winds pushing that moisture right up here into Texas. So that's been part of the story. And of course, the enhanced moisture has increased our rainfall totals. So when you have higher dew points, you're going to have greater precipitation efficiency. We talked about the high rainfall amounts during spring and the flooding that resulted. But in addition, those higher dew points increase the instability. And we've also seen a greater amount of severe weather as a result. So all of those things tied to these enhanced dew points. And why is that? Well, it's that ridge to our south and the exceptionally warm and humid Gulf upstream.
Yeah, it's always interesting to see how much of that all ties together and just how much, just in weather in general, you can never sort of discount any one particular thing because everything just sort of comes back to what has already happened and where some of those source regions are. So, all that being said about dew points, I think folks are now curious as to what does this mean for the summer? Is this trend of top 10 dew points or just exceptionally humid weather going to continue for the whole summer, or are we in for maybe a slightly lower temperature but higher humidity kind of summer, or what is the outlook, do you think, for that?
Unfortunately, it looks like this excessive humidity is going to linger for a while. That will reduce the temperatures, but it's not necessarily going to feel any more comfortable. We'll be talking about those heat index values, which incorporate both the temperature and the humidity. So that's going to play a role. But if we take a look at our summer outlook for June, July, and August, you'll notice that most of the country is expected to be above normal in terms of temperatures. And you might say, well, wait a minute, I thought you said that because we've had such a wet spring, we would be milder. Well, we'll at least delay the onset of heat. But unfortunately, one thing in the climate business, when we're looking at seasonal outlooks, trend is very important. And we've had a trend recently toward warmer summers, meaning that a warmer than normal summer is more likely to occur. Now, you've probably heard people say that weather is random. It's actually the complete opposite of random. Everything that happens in the atmosphere is governed by physical laws. And when we were talking earlier about a rainy day impacting the weather that follows, there's a concept in climate we call serial correlation, a fancy term to say that everything is related in days and seasons. So one season is related to the next season, one day is related to the next day. So it's the complete opposite of, say, Vegas, where you're dealing with a random number, where if you have a bunch of warm summers, then something else is more likely to occur. In the climate system, it's the exact opposite. It's more likely to occur. So one day is connected to the day before it and the day after it. The same with adjacent seasons and even adjacent years. So again, this trend toward warmer summers is more likely to give us another warmer summer. But again, we think that the onset of the excessive heat will be delayed, and we may have uh, fewer 100-degree days than normal. But the main impact is that a day that would have been 100 had we been in drought will be a few degrees cooler than that because of the healthy vegetation and the surplus soil moisture. But the challenge with summer forecasts is that there's not a lot that we can hang our hat on seasonal timescales. A lot of the things that happen during the summer, a particularly strong ridge that brings us a heat wave, or an exceptionally wet pattern where we get a lot of tropical moisture and we have an exceptionally wet July or August. Those things we can't really see on seasonal timescales. We can see that maybe a couple weeks in advance. And when we do, when we see those things arise, we'll definitely make note of that, discuss that in our forecast discussions. But at this point, we really can't see that far ahead. But in a nutshell, a warmer than normal summer overall for the 3 months as a whole, but unfortunately, still quite humid, and hopefully we'll mitigate those high temperatures just a bit as we get into July and August.
Yeah, always so interesting to see how everything connects together like that. And I know a lot of folks are probably happy to hear maybe, hey, fewer 100-degree days, but yeah, the heat index values, it's still probably not going to feel a whole lot better. I think we average, is it like 2,000-degree days or so for DFW
20
every
for DFW.
for okay
Yes.
for through the course of the whole summer,
Right.
and
Slightly more in Central Texas, but 20 for the Dallas-Fort Worth area.
yeah, so yeah, maybe we'll see that numbers try to stay a little bit close to or below 20. I think last year we had 50 something, and I was
Right.
definitely over it by number 10 already. So
Right.
we still have
That's
a long
what
way to
that's
go
what drought conditions can do. Yeah. Hopefully it's the opposite this summer.
for sure. Well, Daniel, thank you so much for coming on. This has been fantastic. So we hope to see you back for another episode in the future. Thank you so much for coming on today.
All right. Thanks so much. I'm honored to be on the premiere episode of On Air.
Thank you again to Daniel for coming on over the past weekend. That was fantastic. If you all would like to see Daniel come back on, maybe later this year and give us a rundown of what El Nino, La Nina mean for us heading into the cool season, into the winter when it is a bigger effect, let us know in the comments and we'll see if we can convince him to come back on and chat with us again. Also, we're going to see how many times that I accidentally call that segment the weather stoplight instead of the weather spotlight. So clearly, I did not think that one through at all, but you all can keep track of that one. All right, we're going to get into the Q&A segment next. And this was a really great question that I had ahead of one of our many severe weather events back in May. It was actually a phone call that I took from an emergency manager in the DFW area. And of course, I'm paraphrasing the question at this point, but she wanted to know why we had been talking about the tornado threat possibly increasing heading into the evening hours. Oftentimes, we associate a lessening tornado threat with a lessening of instability as we head into the evening. So it was a little unusual that we were talking about how the tornado threat could possibly increase later into the evening. And I just thought this was a fantastic question, and what better place to address it than right here. So, in order to answer that, we need to discuss the concept of the low level jet, or abbreviated here as the LLJ. The low-level jet is a belt of strong southerly winds about a mile or so above ground that runs from south to north. And it exists most of the time, not necessarily always, but it is a very prominent feature, especially during the transitional seasons and even in the winter, apart from any other larger weather pattern effects that might also be influencing the low-level jet. But the low-level jet is important to answer this question because it tends to strengthen during the evening and overnight hours, and it reaches its weakest point usually during the day. So you can immediately see that the low-level jet is going to be important for us for severe weather because the source region for this is all of the warm and humid and unstable air over the Gulf of Mexico. So if this low-level jet is going to increase during the evening and overnight hours, then it is going to play a big factor in possibly increasing the tornado threat. So, why is it that this belt of strong winds would increase during the overnight hours? Well, in order to get into that, we're going to take a look at a very crude diagram of what the terrain looks like across the central and southern plains from west to east. So, out to the west, you of course have the higher terrain as you get closer to the Rocky Mountains, with relatively lower terrain the farther east that you go. So, what happens during the evening and overnight hours when you start to cool off is the ground will cool off faster than any of the air above it. So, as energy is radiated back to space overnight, you have very cool air at the ground and relatively warmer air up above that. Now, that's important because at the same relative elevation above sea level, not necessarily above ground level, but essentially above sea level, you have this temperature gradient that appears because of the fact that you are cooling off at the ground heading into the evening and overnight. So this temperature difference at the same altitude results in a pressure difference. So you have higher pressure across the east, lower pressure to the west, and that induces a pressure gradient from high to low pressure because air wants to move from high to low pressure to try to equalize that imbalance if it can. And finally, we have the last component of this, which is the Coriolis effect, which in the northern hemisphere turns winds from it turns winds to the right as they progress. So in this case, if you are moving from east to west and turn to the right, you are now going north. So now we have this additional component of a wind from south to north that is getting added to the low-level jet as this entire cooling process occurs during the overnight hours. Now, why is this important for the tornado threat as we head into the evening? Well, in order to take a look at that, we are going to plot our winds on a hodograph. And a hodograph is a type of graph where the axes are north, south, east, and west. So just like you're looking at a map. And the wind speeds increase outward from the center. So, for example, the wind speed would be 0 right here where the axes cross. The first ring would be 20 miles per hour, the outer ring would be 40 miles per hour, and so on the farther away that you get from the center. So in the afternoon, let's say that our winds might look a little something like this. We're just sort of making up some typical values here for the sake of an example. So in the afternoon, we've got let's say we have a southeast surface wind, so winds blowing from the southeast to the northwest at about 15 miles per hour. Our low-level jet winds, about a mile above ground, are going from due south to due north at 20 miles per hour. And the winds 3 miles above ground are going to the northeast at about 35 miles per hour. Okay, and we said in the evening, our low-level jet winds were going to increase. So just for the sake of simplicity, we're going to keep our surface winds and our 3 mile above ground winds the same as in the afternoon. And we're just going to increase the winds a mile above ground by about 10 miles per hour. So instead of 20 miles per hour, now they're 30 miles per hour. That's the only change that we're going to make. In order to complete our hodograph, we're just going to connect these dots here. And the next component that we need to add to our hodograph is the average storm motion. So that's essentially all of the winds that are steering a storm along. So we're averaging all the winds through the column together. And those might look a little something like this. They're pretty close to one another, but the winds in the evening should be slightly stronger since we increased some of our low-level winds. Now, in order to understand how this affects the tornado potential, we are going to look at the surface and 1 mile above ground winds relative to the storm motion or our average storm motion vector that we just plotted. So these shaded areas here between our average storm motion, our surface wind, and our winds 1 mile above ground are a graphical depiction of what's called storm relative helicity. Now, if you're a fan of roller coasters, that word helicity should be pretty familiar. It sounds like helix or helical flow. So you're thinking corkscrews and loops and all those sorts of things. So right away, you're thinking about spin in the atmosphere. So storm relative helicity describes how favorable storms can ingest low-level spin in the atmosphere in order to take that and tilt it into the vertical and then stretch it into their updraft in order to produce a tornado. A tornado is essentially an extension of a storm's rotating updraft, and storm relative helicity describes how favorable it is for a storm, especially a supercell storm, to take that and ingest it in a way that allows it to produce a tornado. Now, you can see what increasing the low-level winds here did to our storm relative helicity. The area from the afternoon into the evening increased by a factor of at least 2 or maybe 3. And keep in mind, all that we did here was increase our low-level winds by 10 miles per hour. That's it. But we've doubled or nearly tripled the amount of storm relative helicity that is now present. So that's why the low-level jet is so important, and that's how it can be such a contributing factor to tornadoes increasing in the evening. Now, there's still a second component of this that we need to address, which is the instability and how that will affect the tornado threat heading into the evening. So, we all know that instability tends to reach its maximum during the afternoon hours and will tend to decrease during the evening. So, our graph of instability might look a little something like this. Now, as the low-level jet increases heading into the evening, we're going to increase our wind shear and our helicity like we just talked about. So maybe our shear and helicity would look a little bit something like this. And finally, our third element, which is mixed layer sin, or essentially what we're used to talking about as the cap, but in uh, the frame of a mixed layer, so the boundary layer as a whole. So let's say we had no cap through the entire afternoon. It takes a while into the evening, if you were looking at the capping from a mixed layer standpoint, to really take effect. So if you're only looking at a single surface parcel of air, it will sort of lead you astray sometimes. So I really like looking at mixed layer sin, especially as you get into sort of those transitional periods of the day, because it will better describe your capping and your instability through the low levels if you were looking at a mixed layer standpoint. So it takes a while into the evening before mixed layer sin really starts to increase. It's often well into the evening or sometimes not at all, especially if the low level jet is not only simultaneously increasing shear, but also simultaneously maintaining a supply of warm, humid, and unstable air from the Gulf, like we talked about before. So if the low level jet is effective at doing that, you could stay quite unstable well into the evening and overnight hours as well. So I'm looking at this graph and I'm asking the question, well, is there any time frame where all of our factors really come together to increase a tornado threat? So we talked about how in the afternoon, sure, you have the most instability, but you may not have a ton of shear presence. So maybe your storms during the afternoon that you're watching on radar are maybe they're big hail producers. They're really strong. They're healthy, but they haven't been able to tighten up any sort of circulation down low, and there hasn't really been much of a tornado threat yet. Well, as you get into the evening, you're losing some of that instability. So maybe the overall trend on those storms tends to be a little bit downward, especially in maybe in terms of hail production. But all of a sudden, we're now ramping up our shear and helicity. So if I'm looking at an area to target for an increased tornado threat, this is the time window here, centered around 8 p.m. and a little bit afterwards, where all of these ingredients are coming together. Do you have the most instability at this time? No, we lost some of that since the afternoon. But do you still have enough? Absolutely. And that's really all that the environment cares about is just being sufficient. It just wants to be satisfactory. It doesn't need to go above and beyond with the most cape and the most shear in order to produce a tornado. It just has to be sufficient and satisfactory, and that's all that the environment cares about. So this time window here is sort of our Goldilocks zone where you have not too much and not too little of any one particular thing. And this would be the type of scenario where we would be talking about an increased tornado threat heading into the evening hours. All right, speaking of severe storms, let's get into the radar recap. Let's go. Our first radar recap goes back to May 28th when we have this cluster of storms at about 5:30 in the morning getting ready to barrel through the entire DFW metroplex. It already has produced widespread severe wind gusts in excess of 70 miles per hour up through parts of Denton County, and it's continuing to move to the southeast. Let me go ahead and take myself off of the screen here so we get a full view of the reflectivity over on the left panel and the velocity over on the right panel. Now, if you aren't used to looking at velocity on radar, these green and blue colors are all inbound velocities towards the radar. The red colors are outbound velocities away from the radar. And that's all that the radar can detect is winds that are moving either towards it or away from it. So if you have winds that are blowing perpendicular to the radar beam instead of parallel with it, the radar is not going to be sampling most of those wind speeds. So we will actually notice that here as we advance forward in time, as these winds move into Dallas County. It looks like these winds have actually weakened a little bit, although that's not the case. They are just becoming more perpendicular to our radar, which is located down here in South Fort Worth. So as the radar is scanning off to the northeast, more of this wind component is perpendicular to the radar beam, so it's not sampling those full velocities. So in order to get a better picture of how strong these winds are, we're actually going to switch over to TDAL, the terminal Doppler weather radar that is located up in northwestern Dallas County. Now, from the TDAL radar, this radar is scanning these winds essentially straight on. So our TDAL radar is located right here. It is taking the brunt of these winds as they start to move into Dallas County here. And if we look up into southern Denton County, we're actually seeing, rather than just 60 or so knots like what was showing off of the Fort Worth radar, TDAL is actually showing us some wind gusts, or some wind speeds, I should say, as high as 78 to 80 knots, which is closing in on 90 to 95 miles per hour. And that's just 500 or 600 feet above the ground. So a lot of that momentum has the potential to be making it down to the surface at this point. So, since the radar is picking up the essentially the full wind speeds as these storms are moving directly towards it, that's a much more accurate look at the true velocities that are being measured about 700 or 800 feet above the ground. Now, unfortunately, shortly after this, we actually lose the TDAL radar as these storms move through. I'm not sure why, if it was power outage or otherwise, but this is some of the last data that we have from TDAL before it went offline during this event. I want to go back to the Fort Worth radar here real quick and address one more thing that you might have noticed. So, going forward in time, there was this second severe thunderstorm warning here plotted in yellow that we issued that is fully inside of another severe thunderstorm warning that was already in effect for areas all the way from McKinney westward all the way into Parker County near Weatherford. So, why would we issue another severe thunderstorm warning inside of where one was already issued? Well, in order to answer that question, we'll have to go and look at the warning itself. So this is what the severe thunderstorm warning actually looks like. And this was the one issued at about 5:45 in the morning. It's that smaller warning inside of the larger one. And every severe thunderstorm warning comes with these tags on it. So they are not all created equal. And we will assign uh, threats that are based on hail and wind for what we think is the most severe that are of those threats that are possible. And upon doing that, it will assign a thunderstorm damage threat. So this smaller warning that was issued for Dallas County included this destructive tag, and that's important because when that tag is included, it is essentially the highest end severe thunderstorm warning that we can issue. And that is the trigger for things like wireless emergency alerts on your cell phone, plus a whole host of other mechanisms in order to get that warning out. That just a base severe thunderstorm warning with, say, 60-mile-per-hour winds and 1-inch hail, it would not activate those same alert mechanisms. So this was done inside of that bigger warning in order to call specific attention to an area where the winds were expected to be the highest and where the alerts would be triggered to reach as many people with as much notice as possible. So, not all severe thunderstorm warnings are created equal, and that's the kind of situation where we might issue a severe thunderstorm inside of another in order to activate those additional warning mechanisms on a smaller scale where the impact is going to be the greatest. So um, these widespread 80 plus mile per hour wind speeds were, this is a big deal. The entire Metroplex essentially experienced winds between 60 to 80 miles per hour, and some isolated spots did have winds in excess of 90 miles per hour. So relating that to the tornado wind speed scale, an EF0 tornado has wind speeds of 65 to 85 miles per hour. So essentially, the entire DFW Metroplex, plus an even bigger chunk of North Texas than that, was subjected to EF0 tornado wind speeds with this event. So when we are doing a post-event summary and recapping it and saying this was not a tornado event, this was a straight line wind event, we are not downplaying that severity at all because, in a lot of ways, straight line winds are just as big, if not even a bigger deal, than tornadoes at times. And this was one of those times for sure. You had the entire DFW Metroplex experience wind speeds that were essentially an EF0 tornado, or at least wind speeds that correspond to that. And those wind speeds that were in excess of 90 miles per hour, well, that's an EF1 tornado. So these occurred on the scale of, 50 plus miles, as opposed to a typical EF0 tornado, which would only be a very isolated occurrence and very brief most of the time. So, in a lot of ways, this straight line wind event was much more significant and definitely more widespread than just an EF0 or even an EF1 tornado would have been. So, I just wanted to draw some attention to that. This has been the first radar recap. We've got a lot more to do just from the last week of May alone, so be on the lookout for that. We'll be covering more in future episodes for sure. While we aren't going to get too caught up in any one particular forecast, we are going to at least take sort of a broad look and overview at the next couple of weeks and see what the weather has in store for us. And in order to do that, we're going to check out a 500 millibar chart from an ensemble of 30 different models that is averaged together. And this is a great way to get just a general overview without relying too much on any one particular model run, which is probably going to flip-flop over time and eventually lead you astray. So this is a great way to look at the next week or two out into the extended forecast. So right away, when I look at this, I'm immediately seeing this area of high pressure parked across the East Coast through the middle portion of this week. So that's going to put us in sort of tropical easterly flow on the southern periphery of this upper ridge. So that's going to funnel perhaps a couple of weak disturbances eastward and then eventually northward through Texas, and then get caught back up into the broader mid-latitude westerly flow that exists across the western half of the country and then up into the northern plains. So through the second half of the week, we'll have to keep an eye on the potential for a couple of tropical low pressure systems. I don't necessarily mean tropical storms or hurricanes when I say that. I just mean disturbances in easterly flow that have a tropical origin. And if we do get any rain out of that, those are typically very efficient rainfall producers just because they have so much moisture to work with. Now, heading into the upcoming weekend, one thing that I notice is the breakdown of the upper ridge across the East Coast, which has essentially fallen apart. And most of the southern part of the country is now just in weak and kind of disorganized flow. So that does open the door for potentially a couple more tropical low pressure systems in the Gulf to try to get established. We have very warm sea surface temperatures there. So if we can get an easterly wave, move our way in those tropical easterlies, that could be another rainmaker for us. Right now, I still have my eye kind of on Thursday this week. That looks to be maybe the more favorable opportunity. Speaking of Thursday, it's also the summer solstice. So don't forget about that. If you're somebody that likes cool weather, then you can rest assured that the days start getting shorter from Thursday onward. Although that's a little consolation when we still have the three hottest months of the year to get through. So, for the upcoming weekend, maybe some low rain chances still continuing as we just kind of stay in weak flow aloft. Heading into early next week, we were noticing that a couple of these models, at least that are being averaged into this analysis, are still trying to produce a tropical system across the Gulf Coast here, which is highlighted by this general weakness. And it's also interesting that models sort of want to maintain some little bit faster northwesterly flow through the mid-levels into the plains, which is a little bit stronger than what we normally see this time of year. So that could be an opportunity to maybe get a weak front to push south into the southern plains, perhaps offering some additional rain chances from a convective complex or two that tries to get going in Kansas and Oklahoma, potentially pushing southward. So, another thing to watch maybe heading into next week, but far too early to discern any details in that regard. So, our eye will mostly be on the tropics for the next week to 10 days or so, just to see if any of those weak disturbances can get a low pressure system established and offer us some rain chances. All right, that is going to do it for the first episode of On Air. I hope you all enjoyed it. Let us know what you think in the comments. Should we keep doing these? Did you like it? If you did, be sure to share this with anybody else that you think would enjoy watching as well. And hit the subscribe so that you can be alerted for the next episode. Speaking of the next episode, I'm not sure when it's going to be just yet. Weather doesn't have a set schedule, and neither do we really when it comes to these. So we're going to do these when we have time and when we've got a lot of interesting things to talk about, which, let's face it, right now we have enough radar recaps from the last week of May alone for probably half a dozen episodes. So plenty to still go back and take a look at there. Uh, be sure to send us your questions for the Q&A segment. You can email us, you can leave a comment, you can tweet us, or I guess you can post us on X, the platform formerly known as Twitter, um, and use the hashtag on air so that we will definitely see it. The cool thing about this project is that we can make it whatever we want it to be, but more importantly, we can make it whatever you want it to be. So let us know what you think. Send us your questions. If it's something on radar that you saw and want to know more about why we did or didn't issue a warning, or if it's a meteorology forecast concept, or why the forecast looked a certain way leading up to an event, let us know. We're happy to discuss any of those kind of things. So we look forward to seeing your questions there. The links for most of the data that I was showing today are in the description, so if you'd like to learn any more, be sure to check those out as well. Otherwise, that is all from us. Until next time, stay cool out there this summer and stay safe. Have a good one.